Hello, and welcome to the Wired Edge Workshop. If you have watched my last couple of videos, you'll notice that the bright green batteries are still sitting on my bench, and that is because the inverter installation has come to a standstill. There are some parts that are on back order that I probably will not see before the end of the year, and that'll push me back getting the inverters installed and then getting these batteries installed and then fully commissioning that system. So today I could make a video detailing the rest of the process that I want to go through for preparing these batteries, or I could pull them all off, pivot to a different project to do some recording on, and then put them all back on, and I did not want to do that. So today I found it best to just finish up discussing the batteries and how I plan to prepare them for being installed with the inverters, and then do maybe a short discussion on using a subset of these batteries as a short-term or small-scale battery backup power supply. So I'll jump into discussing about the completing the preparation for installing the batteries. So this project I'm working on is the first project that I've done where I'm setting up a battery backup system for a whole house system. Not my first project with lithium-ion batteries, but certainly the largest and most hands-off that I'm looking to set up. So trying to make this a set it and forget it system, allow the inverters to do all their automatic controls, charge and discharge the batteries, and overall just not have to be so hands-on with it. That doesn't mean that we will not come in and check the batteries to make sure over time that the balance is being maintained and we're not hurting the batteries. The batteries are a large part of the system and a very expensive part of the system. So the last thing we want to do is install them and just walk away from it. So what I'm doing to complete and prepare these for being installed is bringing these 24-volt battery modules, and I call them a module. All it is the two 12-volt batteries wired in series. It's just simpler for me to say module than what I just said. So I have three 24-volt modules. And what I chose to do, and this is all based on my research and whatever understanding I've had of batteries in the past, is to take a 24-volt battery charger, and I decided to wire them in series and set them up in their 24-volt configuration and allow them to charge and balance together, instead of the alternative would have been to get a 12-volt battery charger and charge each battery independently. So I'll do the 6 independent battery chargers. The battery charger that I'm using to make the charge to 24 volts, Victron Energy battery charger, 24-volt output. It has a maximum current output of 16 amps. It is software selectable through their Bluetooth connected app, and you can change it to an 8 amp output. I can also select the mode from the face here. So you can see I have it selected to be a lithium ion. And then there's a specific charge profile that's programmed into this. If you want a custom charge profile or select between the 16 and 8 amp output, you use the app, and it's pretty handy. You can see the actual voltage output as well as the current output, and there's a histogram as well. The second component to getting these batteries balanced in their 24 volt configuration is this this battery balancer, and that also from Victron Energy. And what this does, so this is designed for a 24 volt system. We have the 24 volt positive side, the connection to the 0 volt, so the negative side, and then there's a common connection. And the common connection is call it the center tap between the two batteries. So we have the positive, negative of the battery, and then our connection cable, and then that common is connected between the two batteries. It allows this device to measure what they call the upper battery and the lower battery. It's just how it's configured. One of these gets to be called an upper and the other is the lower. And this device is comparing the two battery charges and checking the difference between them. And if they are not within a certain threshold, certain voltage reading that's pre-programmed into here, it'll begin to shunt or move current from whichever battery is higher to the battery that is lower voltage. And in this case, we can see that it's on, and it turns on by itself when the 24 volt system comes up to a predetermined voltage reading. The upper battery is in a high volt state compared to the lower battery. So it's moving current or shunting it from the upper battery to the lower battery. And actually you can see there's an alarm here, alarm LED on, and that's saying that the difference between the upper and the lower battery is too great. So what I want to do is just disconnect my 24 volt battery charger and just let the batteries equalize for a little bit, and then I'll come back to charging again. So I chose this configuration because these batteries can be charged, nominally I can charge them at 70 amps. I can also put higher current into them for a short period of time. This battery balancer is designed for moving tiny little bit of current around. So you can already see that we're hitting the alarm, which means that the one battery is coming up quicker than the other, and that's got to move more current to this lower battery to equalize their voltages. I wasn't going to try to do that with 70 amps being forced into the batteries from the larger inverter chargers. So using this one, I can set it at an 8 amp charge and just keep an eye on it. And that's what I would do most of the time when I've charged these in the past and brought them into Valance, but I've kind of reorganized them and they've been used for some other purposes. So they're not in balance anymore, but I want to make sure they're in balance before I connect them into that system. I think that's mostly what I had to talk about for the battery balancing side. One more comment here is that the theory is that if the batteries are balanced and at the same voltages before I connect them all together in parallel and put them in the large system, they should maintain their balance over time, being charged and discharged from the larger inverters and charger system. We'll see if that happens. Like I said, this is based on my research and some theory right now, and I'd rather be overly protective and cautious than risk ruining these batteries. And hopefully I'm not, overthinking this and gonna end up ruining them in a different way. So that there's always that possibility, but I hope that's not the case. So I'll do a quick little overview of what maybe a small scale short-term battery backup system could look like. And so if we took, this is for right now a whole house, system where the inverter chargers are connected to are feeding a sub panel in the house, and the from the main panel, those inverters will get a 50 amp circuit, and from that they can charge the batteries from the grid. But then in a loss of grid power situation, it disconnects and it begins to power that sub panel and pull from the batteries. If you were ever had concerns, or lived in an area that you could set your clock by the times that the grid goes down, and you may know the exact amount of time it takes to bring it back up. Perhaps you're just in an area that happens. You could consider say a subset. So one of these 24 volt modules, so 2 batteries, you could set it up with a charger, a battery balancer, and then I also have this is a 1200 watt inverter. And say you had a deep freeze or chest freezer, or even your refrigerator freezer in your kitchen. This would be sufficient enough to power those in the time that the grid is down. If you have a big chest freezer that's full of beef, pork, chicken, bunch of vegetables, whatever, you may have more money tied up in that food in that freezer than what the cost of these batteries, charger, and inverter is. And in that case, maybe it's a smart investment to consider some method of backup power to protect your freezer and what's inside of it. If you have, if your grid goes out and it's only short term, stuff may never thaw quick enough to be a problem. But there's something to be said about being prepared for something like that. Another case, or another use for these would be for some emergency lighting. Say you maybe have a CPAP machine or an oxygen generator. Some of those may have built-in backup battery power, but maybe they don't. Something like this could be handy and certainly useful for that. On the refrigerator side, so I have an older refrigerator. It's an older Sub-Zero, not as efficient as the newer versions. And I haven't tried it since I've had it running for a while and all cooled down inside. I did try it when I initially bought the refrigerator and had to clean it out, so it was warm, and I connected it to the system, the 2 24 volt batteries, and this inverter, 1200 watt inverter, and it took about 3 times before the refrigerator was able to start. The inverter kept hitting its overcurrent protection, and that's just because of the inrush current, surge current from the compressors starting on that, both compressors starting the refrigerator and the freezer. Now that it's cooled down internally, it may not be an issue because both the compressors may not be trying to start at the same time. And so I also have a kilowatt meter connected to my fridge, and I'm seeing that the refrigerator cycles about 3 times every hour. Same with the freezer. They may not be in unison, but either way, with 2 of these batteries and the information I have from the kilowatt meter, I could run my refrigerator for 20 to 24 hours straight, letting it do its own cycling. So that's certainly a consideration for if you think you want a short-term backup power. You want to pair it with a generator, because this charger plugs into one 20 volt connection. You run your generator, charge up your batteries, shut your generator off. You could also pair it with portable solar panels, get some sunlight helping to recharge these if you have a more extended loss of power. Another neat usage for these batteries. So I went on a camping trip and, take our own food with. And what we did was we had a 24-volt refrigerator, one of those rectangular ones, and took 2 of these batteries, hooked it up, and I think we ran a week before even considering recharging them. And I don't know that I needed to recharge them yet. I just was near power and decided I would recharge them. That was pretty handy. It worked better than having to plan way ahead and say, well, I want to freeze a bunch of stuff, throw it in just a nice insulated cooler and let everything come up out of its deep freeze. So there's that to consider. It doesn't have to be a whole house system. Just if you want to consider being prepared or planning for something, the components are there, and it's not a whole lot to put together. So if you've stuck with me this long and made it this far through the video, it means you like what I have to say, or at least find it maybe a little bit interesting. So I'd appreciate it if you subscribe to my channel, maybe leave a comment, and or tell somebody else that might be interested about this video. Thank you.